Grade 9 quadratic inequalities, more like year 9, 5 marks, last question. We're told the area of the rectangle is greater than the area of the triangle. Well, first of all, to calculate the area of a rectangle, it's simply the length multiplied by the width in any order. If you've got two terms, always place that inside single brackets. Hence, we're going to have 3x minus 2 in brackets multiplied by x minus 1. And that's greater than the area of the triangle. As it's a right angle triangle, we know a triangle is half of a rectangle. Hence, to calculate the area of a right angle triangle, I can just simply do the base multiplied by the height and then half it. So in this case, I'm going to have x multiplied by 2x all over 2. On the left-hand side, expand my double brackets. I've got 3x times x will give us 3x squared. 3x times negative 1 will give us negative 3x. Negative 2 times x will give us negative 2x. And negative 2 times negative 1, we know negative times negative gives us a positive, so plus 2. And that's going to be greater than, on the right-hand side, 2x times x will give us 2x squared. And it's all over 2. Collecting like terms on the left-hand side, I've got 3x squared, no other term ending in x squared. I've got negative 3x, subtract another 2x. They're like terms as they both end in single x. Negative 3x, take another 2x, will simplify to give us negative 5x. And I've still got plus 2. And that's great. And on the right-hand side, I know 2 over 2 will cancel, going to leave us with positive x squared. As I've now got a quadratic in terms of x, and I've got more positive x squared on the left, I'm going to bring every term across to the left to get my quadratic equal to 0. If you bring a term over an equal sign, it changes sign. Hence, the opposite add x squared will be subtract x squared from both sides. On the left-hand side, 3x squared, subtract 1x squared will give us 2 lots of x squared. I've still got negative 5x. I've still got plus 2. And that's still greater than, on the right-hand side, that x squared minus x squared will cancel. Hence, we're left with 0. Greater than 0 is where my graph is above ground. My next step is to put my quadratic equal to 0 and solve for x to find my two roots. As I've got 3 terms, a quadratic in terms of x, I know it's going to factorise into what we call double brackets. As it starts 2x squared, as 2 is prime, the only way to get 2x squared is to have 2x in one bracket and single x in the other bracket. As my number term is positive and the number in front of the single letter is negative, the only way for that to happen is for both brackets to be negative. Also, looking at my number term, this is prime. The only way to get a prime number is 1 itself. So I can really quickly figure out that this bracket has to have negative 2 and this bracket has to have negative 1. As I know 2x times x will give us 2x squared. I know 2x times negative 2, that will give us negative 4x. I know negative 1 times x will give us negative x. And negative 1 times negative 2, negative times negative gives us a positive, so plus 2. So x squared will stay. I know negative 4x, subtract another single x will give us negative 5x. And I've still got plus 2, which is exactly what I wanted. As I'm solving, I now place each single bracket separately equal to 0. If I put 2x minus 1 equal to 0, the opposite of minus 1, if it goes across an equal sign, will become positive 1. And the opposite of times by 2 is divide by 2. And 1 divided by 2 is a half. So one solution is x equals positive half. If I put x minus 2 equals 0, the opposite of minus 2, if it goes across an equal sign, changes sign. Therefore, x equals positive 2. Now I've got my two roots. I draw a quick sketch. You get no marks for the sketch. The sketch is purely to identify the region. So these are my two values for x. They're my two roots. That's where it crosses the x-axis, in this case, positive a half and positive 2. As my quadratic was 2x squared, as the is positive, therefore it's a parabola, i.e. U-shape. As I want my quadratic to be greater than 0, I know greater than 0 is where my quadratic graph is above ground. Well, ground level is my horizontal axis. So it's above ground here for two separate regions. It's above ground for this region going off to the right, and it's also above ground for this region going off to the left. It's below ground, in this case, for this region here in the middle. As I have two separate regions where my quadratic graph is above ground, therefore I have two separate inequalities. I can see my quadratic graph is above ground for values of x here greater than positive 2. I can also see that my quadratic graph is above ground for values of x less than positive a half. We should always check at the end whether both our solutions are valid, because here if x is less than a half, substituting into the width of the rectangle, here instead of having x, I'll substitute a half, so I'd have a half subtract 1. But I know a half subtract 1, that will give us negative a half, and I can't have a negative length. Therefore, x cannot be less than a half. Therefore, the only possible set of values of x is greater than 2.